Welcome to our today's lesson in mathematics, and today we are going to look at what we call the spatial patterns. As earlier on, we've looked at the number patterns, or what we call sequence of numbers, but this time now we want to see if we can, this sequence of numbers or number pattern can be represented geometrically. When we say it being represented geometrically or mathematically, here we expect to represent this series using mathematical or geometry shapes. Now, this is something that is common and it can be used anywhere. And while using this, I want us to put in mind things like sticks. We can have a stick, and these sticks may be arranged together to form maybe a certain shape. If we have maybe 4 sticks, we can put them together to form a square. So we shall say one square has been formed by 4 sticks. So I want us to look at the spatial patterns, and we are saying the spatial pattern is a situation where now this time we are going to generate the patterns using geometric shapes and see how it moves on. Now I want us to consider this and just at your own time and see what do you realize here. Can you look at this? If we take 4 sticks, when you take, for example, when I talk about 4 sticks, if you may look at this, I may have 4 sticks. This is the first stick, this is the second stick here, and then we have other 2 more sticks coming in. And when 2 more sticks comes in, it comes maybe here. I want you to slightly see that we are going to form something like a square. We shall form something like a square. You see that? This is a square. Now, this square, it's a mathematical shape. It's a geometry shape. But now, when you look at spatial patterns, it has been formed by 4 sticks. If I may represent by drawing, you'll find that we have there are 4 sticks here. I'll use the dots to represent the sticks. Now, there are 4 sticks that have formed this pattern that we are calling a square. Now, so when we look at spatial patterns now, particularly here, we are looking at a pattern that is going to form a sequence using geometric shapes. And when we talk about geometrical shapes, we are looking at the common shapes that you know: a square, a rectangle, a hexagon, a triangle, and so on. These can also be used to describe number patterns. Now, let us look at a spatial pattern and also write down what we think is its number pattern. So this is just a geometrical shape, but we are going to have several and see what it will form. What it forms is a spatial pattern. Now, we have a shape. This is an inverted square. One square is being made up of 4 sticks. So we have, this is one, this is another one, and this is another one. So they are about 3. Now, this, what I've drawn is what we call spatial pattern. the spatial pattern. But the same can be represented using what we call the number pattern. Now, between the dots, I want you to take that to be sticks, such that now in this first one, it is formed by 4 sticks. So the number pattern, what I have below it, is the number pattern. Number pattern for the first one here is 4. For the second part here, just take your time and count the sticks. This is 1, 2, 3, 4, 5, 6, 7, 8. So it is 8. The third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12. So it's very simple. The spatial pattern, we have the first inverted square, the second one, and then the third one. But if we change it to a number pattern, we shall write 4, 8, then 12. If you are very keen, you realize that 4, 8, 12 is forming a certain pattern of which is increasing by 4. It is increasing by 4. If we have a pattern where it is increasing by 4, already we can identify that if we were to go for the next shape, it would increase by 4. Therefore, it will be with a 16. It will be 16. And that means here we shall have how many squares? That's what you're going to look at. We can simply use number pattern to develop, to identify the number of patterns that exist. So this is just to illustrate the spatial pattern and relate it to the what we call the number pattern. Spatial pattern starts with a very simple geometric pattern or geometric shape that you always know. And then now it starts adding itself up. I want us to consider this. I want to see how a spatial pattern now keeps on increasing and to form a series. Now, if we take, for example, an ordinary square, this one has been formed by 4 sticks. If we say we want the 2 now, we shall move ahead and have these 2 squares. Then we can form the third one. That is the third one. Now, what is the starting design? The starting design here is a square. A square here has been made of 4 sticks. It would be odd that then the next one, which has 2 squares, should have 2 sticks. But it should have extra 2 squares, which means it has 4, which is 8. But now look here. If we count the sticks here, 1, 2, 3, 4, 5, 6, 7, you find this is 7. And if you count this one here, 4, 5, 6, 7, 8, 9, 10. This is 10. So the spatial pattern tells us we have 1 square, 2 squares, 3 squares. However, the number pattern tells us 4, 7, 10. Meaning it is increasing by how many? It is increasing by 3. It is increasing by 3. So the pattern can be simply developed. So it can be developed in a way that we shall have either a common difference, which will just be identified by simply counting the number of sticks that is making up the shapes. Or we can have it concluded by doing it mathematically. I want us to see how we can come up with a way so that we can form a rule that will connect the number of objects and the sticks required to produce the number of designs. Is it possible for us to have the numbers of the objects that we have, that the geometrical shapes, and see what is the relationship will it form, or which rule shall we maintain so that we are able to tell that there is a rule formed or connecting the number of shapes, that is the sticks, and the number of shapes and the number of sticks that is required to produce a number of designs. Let us look at a hexagon. So this one I was only illustrating that using the spatial pattern, we can also form a number pattern. And here we are where we have a common difference of 3. So let us see now the outcome about the rules. You all know what a hexagon is. A hexagon is, especially a regular hexagon, is a shape with 6 sides which are equal. Now we are going to have it that one is one hexagon. We said that in a spatial pattern we start with a very simple geometric shape. So this is a hexagon. If there are 2 now, we shall have 2 of them. So we are joining sticks. Remember, at every given interval, these are the sticks we are joining. Every corner is a stick on its own. And we go on and we get the, if we had 3 hexagons, we have 3. One hexagon is made of 6 sides, which means we shall join the sticks 6 times. 1, 2, 3, 4, 5, 6. 6 times. If that is the case, then for 2 hexagons, it will be again 6 more. So what are we saying here? The rule will stand. And the rule here is that to get the number of sticks that will form the pattern, we shall put a formula that number of sticks the number of sticks used is equals to number of sticks used to make one shape, which is how many sticks? 1, 2, 3, 4, 5, 6. So there are 6 sticks. So I write there 6 multiplied by what? The number of hexagons. And the number of hexagons formed depends. If we are to talk about one particular hexagon, we shall say 6 times the number of hexagon, and it's 1. You place 1, so the answer is 6 sticks. If the hexagons are 2, to find the total number of sticks used to form 2 hexagons, it will be 6 multiplied by number of hexagons, 6 sticks multiplied by number of hexagons, which is 2. So you get total of 12 sticks. And you can count, this is 6 plus 6, that's 12. So if it is 3, like the one we have here, we shall take the number of sticks is equals to number of sticks used to form one geometry shapes multiplied by the number of what? The number of the hexagons, which is 3. So for this case, we require to have 18 sticks. However, now from this we are coming up with a certain pattern. Someone will ask you, how about if the hexagons are 5? How many sticks will be used to construct or to come up with 5 hexagons? So we have said the formula is the number of sticks used. So there is normally given by 6 for 1 multiplied by the number of hexagon we require, that is 5. So if we want to construct or to draw 6 to create 5 hexagons, we shall require 6 times 5, which is 30 sticks. And when you talk about 30 sticks, take 30 sticks simply like that, you arrange it together, you'll come up with good 5 hexagons. So that is the rule, that the number of sticks equals to the number of sticks per shape multiplied by the number of shape. So it is therefore necessary for us to know this. It is necessary for us to know that this formula applies at any given time on each independent shape. This is a hexagon. We shall move to a square and define the relationship changes. So it's upon you to know that which shape are we talking about and how many sticks are making up that particular shape. After seeing the spatial pattern, study it very well and find out what rule governs if we want to give the formula for the number of sticks used to give us the total pattern. So let us look at various questions describing spatial patterns. So we want to draw and describe a spatial pattern. The question reads as follows. Now, in this question, we are asked the following. First, draw the next 2 shapes in the spatial pattern given below. Then 2 Now, draw the next two shapes in the spatial pattern shown. Then write the spatial pattern above as number pattern in regard to the number of sticks used to make each shape. And finally, describe the pattern by stating how many sticks are required to make the next term in the pattern. Now, before I start in this question, I want us to agree and see the sticks and where they reach. Now, I want us to take from here to here. This is one stick here. So there are still, these are sticks. So we have a stick like this. So this is a stick up to halfway. This is another stick. This is another stick. This is another stick. I want us to understand this particular pattern in that way. So where we have the dots, it means that between the dots, it is one stick. Between the dots, it's one stick. Now, so that's what we have. If you look at the diagrams closely, you look at the first one. The first one forms a very simple letter that we know. It forms a letter that we can call it capital letter H. This capital letter H, in this case, it has been formed by several sticks. So this is the first stick is here. So I can illustrate. This is the first stick from here to here. Another stick is here. Another stick is here. Another stick is here. And this one here. So you realize this is 1, 2, 3, 4, 5. So we can now agree simple that a letter H on its own is formed by 5 sticks. So now let us start developing the pattern and now see if we come to draw even the next pattern, how many sticks is it going to give us? So the next pattern here you can see it is 2 letter H. We have combined 2 letters. We've combined the patterns. But now, how many sticks have been added? So we have this one as 5 sticks. This one is 1, 2, 3, 4, 5, 6, 7, 8. This one is 8 sticks. This one here, we have H, 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 3 of them. This is 2 of the H letters. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 sticks. So they are asking us to simply come up with the next 2 shapes. If we want to come up with the next 2 shapes, what are we supposed to do? So before we move into that, I want us to know, it's a shape we want to look at. But before I draw the shape, I want to use to answer this question so that I now come with a space where I'm going to write. And here, this question is saying, write the spatial pattern above as number pattern in regard to the number of sticks used to make the shape. So that question is simply telling us to study this. This is 5, 8, and 11. So the relationship there, from here, you'll find that to answer question B, let us start with question B, that to write the spatial pattern as the number pattern, it is 5, then 8. We are just counting the sticks. Then 11. The relationship is that 5 to 8, we are adding 3. For 8 to 11, we are adding 3, which means that the next 2 shapes, if we are to go for it, we shall add 3 here to get 14, add 3 again to get 15. So the next 3 shapes we are going to draw should actually agree with the pattern that we have. So let us confirm that. So the sequence, the number pattern that they require is this. This is the number pattern, the number pattern that they require for this particular spatial pattern. 5, 8, 11, 14, and 5, 8, 5, 8, 11, we are adding 3, 14, that is 11 plus 3 is 14, 14 plus 3 is 17. So that is the number pattern that we require to answer that solution B. Now, to answer now this question, we needed the next 2 shapes. The next 2 shapes so that we can now see what we require. This is the first shape, this is the second shape, this is the third shape. We want to go for the next two shapes. Now, here we are with the next two shapes. If you look at these next two shapes, we said it's a special patterns, no worry. Hold it on it and do what? Just draw. So if we have to draw, this is what we have. So we counted the sticks. Remember how we are counting? 1, 2, 3, 4, 5, 6, 7, 8. Put 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put 11. This is the next shape from the number pattern that we have. We see that we are supposed to have 14, yet to be confirmed. That is from the number pattern. How about from the spatial pattern? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14, and we have 14 there. That's very correct. We have 14 sticks making up the fourth shape. The fifth shape, again, we expect the number pattern telling us it should be 17. But let us look at the spatial pattern and see what it will give us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 sticks. 17 sticks from the number of, from the spatial pattern. 17 sticks from the, what we call the, this is the number pattern, and this is from what the spatial pattern. So what are we realizing here? They have asked us to describe the pattern by stating how many sticks are required to make the next term in the pattern. The next term. Now, when we look at the pattern, we can go as many as possible, because up to this is up to this shape, we have 17. The relationship is adding 3, 3, 3. So we can have the next one as 20, 23, 26. We are adding 3, 3, 3. And if we are adding 3, at any given point, we should be able to know that the number of sticks required to make the next shape, we only need to increase it by 3. And these, remember, are sticks. So don't take a stick from up to down. That's why I've put the dots to separate the sticks. Next question. Draw the next two shapes in this spatial pattern. Draw the next two shapes in this spatial pattern. And the pattern that we have the following patterns. These patterns still are made up by the sticks. Take note of that. So we are asked to draw the next two shapes in this spatial pattern. For us to come up with that, first we need to know how many sticks are being used to make one pattern. So the first pattern that we have is an ordinary triangle. A triangle has got 3 sides, and therefore it has got 3 sticks. Second one, it is 2 triangles with a total of how many sticks? These are 6. Then we have the other one with the 9 sticks. So if they are asking us for the next, I'll go step by step as I draw it. So for the next one, I'll expect to have 4 triangles and then 5 triangles. So remember, this is 3 sticks, this is 6 sticks, this is 9 sticks. So the next one I'll expect to have we have 4 triangles. That's where we have, those are 4 triangles. At any given time, we have the sticks making up the triangle like that. Then they are asking us for the next, how many sticks? They are asking us for the next 2 shapes. So this is the first shape that we have. So we go in for the next shape, which will mean we shall have 5 triangles. One, two, three, four, 5. Now, if you notice here, the number of sticks here, this is 9. This one is going to be 12. And you realize this is 15. So if that is the case, this is the next shape that we are required to have. Then the next question is asking us to simply come up with what we call the number pattern. This is a spatial pattern for the triangles. We have those shapes. Now, what is the number pattern? For us to come up with a number pattern, it's just simple that we count the number of sticks here. The number of sticks for the first shape, it is 3, then 6, then 9, then 12, then 15. That number, as I am stating, forms the number pattern. And when we say the number pattern now here, is 3, 6, 9, 12, 15, and so on. Already we have formed a sequence of numbers, and the same sequence has been developed from the spatial patterns. That's what we have. If that is the case now, look at this table, complete this table. Having known this, having drawn this, complete the table that follows. To complete this table, we need to know how to approach the table, and we are saying that they have given us an example. If we have one triangle, it requires how many sticks? It requires 3 sticks. So how many sticks would 2 triangles require? We had already seen the number pattern. You can still fill it, but let us count this one. 1, 2, 3, 4, 5, 6. So 2 triangles requires 6. 3 triangles requires 9. 1 times 3 is 3. 3 times 2 is 6. 3 times 3 is 9. 4 times 3 is 12. So this is what the relationship will be. So the table can be filled, and it will definitely, if someone gives you and says, give us one for 6 triangles, you'll multiply by 3, and you find that the total number of sticks required is the number of triangles times 3. That is number of sticks per triangle. So this is when we fill the table. How can we describe the rule? How can we describe the rule connecting number of sticks required to the number of triangles? That is a question on its own. I want you to write it down. Describe the rule. Describe a rule connecting describe the rule connecting the number of sticks required to the number of triangles produced. Now, this is a rule that we want to come up with. And it's easier from the little spatial pattern that we have, it is easier for us to come up with that. One triangle, two triangles, three triangles. One triangle, 3 sticks, two triangles, 6 sticks, three triangles, 9 sticks. If 3 triangles is 9, 2 is 6, and 1 is 3, then it means that we are multiplying simply the number of triangles by the number of sticks per triangle. So the rule here would mean that if we are to come up with a rule here, then the rule would say that the rule would be number of sticks required is equals to number of sticks per triangle multiplied by number of triangles. That is what we shall have. Number of sticks per triangle multiplied by number of triangles will give us total number of sticks required to develop a certain pattern. So if this is the rule, then the last question under the same asks the following. I want us to use the rule that you have generated here and predict how many sticks are required to make 20 triangles. How many sticks are required to make 20 triangles? So we want to use the rule that we have written down here. The rule that we have written here, number of sticks required is equal to number of sticks per triangle multiplied by number of triangles. So if that is the case, they are asking us, how about 20 triangles? So for 20 triangles, we shall use the rule required. The number of sticks required will be number of sticks per triangle, which is 3, multiplied by number of triangles that we have, which is 20. So we shall require a total of 60 sticks. Simply for 100, it will be 100 times 3, that is 300 sticks. That is how we approach a spatial pattern and relate it to what we are now calling the number pattern. So let us look at further questions related to the similar ones and see how we are supposed to be approaching them. And we should be able also to just look at the spatial pattern and then we come up with a number pattern. Or take the number pattern and come up with a spatial pattern. It is always good that we should be able to convert either to the spatial pattern or from spatial pattern to the number pattern. And always when you have that, find out the rule that governs that pattern. Now, for this pattern that we have, I want us to use the pattern that we have here, the spatial pattern we have, to answer the following questions. In this question, from the shapes we have here, question 1, draw the next two shapes. Draw the next two shapes. Question 2, write the spatial pattern as number pattern. Write the spatial pattern as the number pattern. 3, describe the pattern by stating how many sticks are required to make the first term and how many more sticks are required to make the next pattern, to make the next term in the pattern. So first, let us start with the first part. I'll draw it above it. So if this is the first one, this is one triangle, two triangles, three triangles. So I expect the third one to have the fourth triangles. If I may use a red pen, you will see what I'm trying to say. And so the red part is the one which is giving me the increase of the pattern. So that is what I expect to have. So I'll expect you to have a pattern of this type. And then the last one, I'll expect us to have so that is what I expect to have. So I'll say that the first one, the second one, the third, the fourth, and the fifth. So that is it about the first part. Part 2, write the spatial pattern as number pattern. First, let us identify how do we get this spatial pattern. The spatial pattern we've drawn the diagrams. How many sticks are making each diagram? This is 3 sticks. This one is 1, 2, 3, 4, 5 sticks. This is 1, 2, 3, 4, 5, 6, 7 sticks. These are expected to be 9 sticks. That is 1, 2, 3, 4, 5, 6, 7, 8. That is we have 1, 2, 3. 1, 2, 3, 4, 5. The triangles we have are extra. We need 1, 2, 3, 4 triangles. 4 triangles. So this one is extra. Good. So the shape we have for 1, 2, 3, 4, 1, 2, 3, 4, 5. So I want us to have that correction done. So the next what I had given is the next 5th and 6th. But for the next 4th and 5th, this one will be the 4th and this one will be the 5th. I expect it to give me about 11. So let's confirm 1, 2, 3, 4, 5, 6, 7, 8, 9 sticks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the spatial pattern is giving us the number pattern in form of the following. In form of 3, that is we are looking at the number pattern. It will be 3, 5, 7, 9, 11. So it is a sequence of odd numbers, or we can say the next pattern is simply given by adding 2 every given time. We are adding 2, 2, 2. So if we want to come up with another shape, we shall bring 2 sticks. And there we are. If you bring in 2 sticks here, you'll find that a stick will come. We shall need just a stick there and here. We are already complete. That's why you are saying the pattern here, we are adding 2. 2 at any given interval. Or alternatively, if we are not adding 2, we are simply saying it's a series of odd numbers. That is what we have. So to describe this pattern as a number pattern, that is what we have. So we are done in the first and second part. The third one is asking us to describe the pattern by stating how many sticks are required to make the first term. Let's start with that. The first term in this particular case is the first diagram. And if you look at the first diagram, we have good sticks. This is 1 stick, this is another stick, and this is the third stick. So there are how many sticks? 3 sticks. So how many sticks are required to make the first term? We are saying it is 3. Right? Then we move ahead, and how many more sticks are required to make the next pattern? For us, following what we have here, we want to ask ourselves, how many more sticks do we require to make the next pattern? It does not matter where your pattern comes. If we pick at the third pattern, or we pick at the 6th, or we pick at the first one, there is some connectivity between the first pattern and the second pattern. Let us look at it. This is the first pattern with 3 sticks. This one is the second pattern with 5 sticks. And this is the third pattern with 7 sticks. What is happening? We are adding 2 to get the next pattern. We add another 2 to get the next pattern. And the question is asking us how many more sticks. The word here is more sticks. How many more sticks are required to make the next pattern? And if that is the case, how many more sticks? Then we are saying we require how many more sticks? It is the next minus the previous, which is 2. So we require 2 more sticks. 2 more sticks. If that is the case, this one can be found, whether you're using a spatial pattern, you'll get it is 2 more sticks. If you are using the number pattern, you'll find it is what we call the common difference is 2, and that 2 is what is going to give us the more sticks we require to come up with the next pattern. So in general, you should have learned today that when we talk about the number patterns, we are saying that the spatial patterns and this that you are calling the number patterns are simply related. And if they are related, we should be able to develop a number pattern basing on the special pattern diagrams that we have. We need to observe and identify how many sticks are required to make the first pattern of the spatial diagram. And having gotten the first shape, how many sticks it makes, then we move ahead and find out. The relationship will clearly be elaborated when you have the special pattern and the number pattern. So it is always clear that the patterns were developed and they are related. If you cannot apply the number pattern, refer to the spatial patterns and you'll always find the rule governing the two as you move on. So as we go on, I want us to prepare for the next class where we shall still be referring to the number pattern, but now the only difference now here, we shall consider the spatial diagram and put them, the spatial patterns, and put them on a table, such that we shall be able to identify how many of the sticks are required at any given time. That is it for today. When we meet in the next class, we shall be looking at the tables and rules. Thank you.